temperature dependence of resistance. Okay, temperature dependence on what? On resistance. Three cases. पहला conductor, how resistance changes with temperature in case of conductor. Another is semiconductor, how the semiconductor.
Insulator.
Third is insulator. Insulator. Okay. चले conductor case रे कौन है? When temperature increases, resistance
increases.
Temperature increases, then resistance increases.
A
Okay.
semiconductor
Temperature increases, resistance also increases. Resistivity also increases. Resistivity also increases. So this is called positive or negative?
Positive.
Positive temperature coefficient of resistance. Positive temperature coefficient of resistance. Okay. Or you say resistivity. Positive temperature of coefficient of resistance or resistivity alpha. Alpha is positive. When temperature increases, alpha resistance or resistivity also increases. So alpha equal to change in resistance RT minus R0. Original resistance are 0 degree and change in temperature also. Okay. Then resistance at T degree is how much? R0 whole into 1 plus alpha delta T. Resistivity at T degree Celsius 0. Resistivity at 0 degree Celsius 1 plus alpha delta T. Temperature dependence on resistance in case of conductor. Right? So resistance increases. Okay. Conductor resistivity also increases. In which case? In case of conductors or metals. चला हम लोग ग्राफ करेगा. कौन कौन ग्राफ था? कहाँ ग्राफ?
Resistivity or temperature?
Resistivity versus temperature. वो कैसे? निक्रोम. उधर निक्रोम और कॉपर. और वो कैसे? कॉपर. Temperature. Okay. Temperature versus this is nichrome, this is your copper. So nichrome रे behavior कौन? Copper रे behavior कौन? इधर तो increase करियो. तो direct straight line हो y इक्वल mx plus c. बुझले? nichrome के. हला? कडाला हमारा follow करची y इक्वल mx plus c. ये ग्राफ straight line ग्राफ. आओ इधर भी increase करियो but non-linear increase in case of copper, right? अच्छा तो न्यूमेरिकल टा करियो. Calculate resistance at T degree Celsius, that is resistance at T equal to 100 degree Celsius. Calculate resistance at 100 degree Celsius of a metallic wire if resistance at 0 degree Celsius is 50 ohm. Resistance at 0 degree Celsius is 50 ohm. Calculate resistance at 100 degree Celsius. Okay. If resistance at 0 degree Celsius is 50 ohm, take alpha equal to 2 into 10 to the minus 3 degree Celsius inverse. So you have to calculate resistance at T degree Celsius. Thorough calculation. Question होची calculate resistance at T degree Celsius if resistance at 0 degree Celsius is 50 ohm अल्फा इज 2 into 10 to minus 3 तब कौन पड़िबो RT equal to केते पड़िबो आकें RT equal to फॉर्मूला कौन पड़िबो
T minus
R0 whole into
R0 whole plus alpha
alpha delta T डायरेक्ट R0 जगह केते पड़िबो 50 ohm
50 ohm.
अल्फा जगह
2 into 10 to
minus
minus
3
3.
delta T 100 minus 0 so 51 plus 2 into 10 to minus 3 এটা কেতে change in temperature 100 calculate this much of ohm okay এটা রেজিস্ট্যান্স और रेजिस्टिविटी ही करियो टेम्परेचर ग्राफिकल रिलेशनशिप केता ला कैलकुलेशन करले देखा करछो बोले 50 होल इनटू 1 प्लस एटा केते 200 2 into 10 डॉलर एटा -1 हे जो एटा -3 into 100 एटा 0.2 अब करो फाइनल केते हो को
Sir, 60 ohm.
60 ohm 60 देखा 50 into 1 केते 50 ए 50 टा इतना मल्टीप्लाई होला 100 10 to minus 1 good 50 plus 10 how much 60 एंते कैलकुलेशन करियो then comes to case 2 semiconductor ए रेट आछे recording case of semiconductor कौन बोलते सोच कहलो रेजिस्टेंस डिक्रीज करना इंक्रीज करना
Decrease कर.
गुड रेजिस्टेंस डिक्रीजेस विथ इंक्रीज इन टेम्परेचर सो दिस इज योर नेगेटिव टेम्परेचर कोएफिशिएंट ऑफ रेजिस्टेंस व्हाई तो काइंड भावुच रेजिस्टेंस डिक्रीज करछि ना व्हेन टेम्परेचर इंक्रीजेस इलेक्ट्रॉन होल पेयर्स आर प्रोड्यूस्ड more number of electrons generated so conductivity increases due to increase in temperature so this is generally negative temperature coefficient of resistance or resistivity so how is the graph inverse yes resistance inversely proportional to temperature so hyperbolic
Hyperbolic.
resistivity or you take resistance this is your temperature hyperbolic graph is hyperbolic okay this is also case of carbon insulator also in which case also in case of insulator that is carbon in case of carbon resistivity or resistance decreases with increase in temperature hyperbolic stop